This experiment is called the disappearing cross experiment, and we're going to use this to look at the effect of temperature on reaction rate. So we're going to carry out the reaction between sodium thiosulfate and hydrochloric acid, and we are going to be looking for a colour change. And when our colour change happens, it should mean that the cross that I've got sitting, my laminated cross sitting under the conical flask there, will no longer be visible. So by timing how long it takes until the cross disappears, we're timing the same amount of product being formed to give the same depth of colour. So what we need here is 10 centimetres cubed of our sodium thiosulfate. So we're going to measure that out in our measuring centre here. Whoops, try to at least. Okay, get another drop in there. Okay, so we have 10 centimetres cubed of that. We're going to put that into the conical flask along with 40 centimetres cubed of water. I get in there. Okay, so there's our 40 centimetres cubed of water. And then we need to measure 5 centimetres cubed of hydrochloric acid. So we have a rinsed out measuring cylinder here. So 5 centimetres cubed of this. And we're going to put that into a test tube. And then because we're measuring the effect of temperature, we're going to need to have our chemicals at different temperatures for each of the different runs in the experiment. So we're going to make use of a water bath. I'm going to put a photograph up in a minute of a water bath that we can use to put lots of samples in. So that's the one we're going to use in the lab. I'm just going to use a beaker of hot water for this purpose, then I don't need to carry a big water bath all the way over. So my makeshift water bath is just a jug there that has water in it that is at 50 degrees. So I'm going to just sit my test tube and my conical flask in there for a few minutes so that they reach 50 degrees, and then I will record the temperature. So I'll pause this so you don't have to watch that happening. Okay, so those have sat there for 5 minutes to take on the required temperature. So if I read that off now, so that one is 42 degrees. So we planned for a range of temperatures. So those are the temperatures we're aiming for, but we must of course record the actual temperatures we have. So without taking too much time to allow these to cool down, we are going to mix, swirl, and then time how long it takes for our cross to disappear. So mix, swirl, time. So watch carefully what's happening inside our mixture there. See if I can bring you over here. There we go. So we always look from above for our cross. So I'll just show you from the side here. Can we see it's starting to go a bit cloudy? So we just need to wait until we can no longer see that cross. Show you the time there, then you can decide what you think for this particular one. There, I reckon that's gone there. Just that, right, so that was 101, I think we can call that there. Right, so we can see that during the reaction, whoops, I'm stuck there, our mixture has gone all milky here. So we've had a reaction that has produced a solid, so we've got a precipitate there. And because there's been more and more precipitate produced over time, that has meant the mixture's got more and more cloudy. And then once we get to the point where there's enough solid produced that we can no longer see through, then that's when our cross has disappeared. So I have already repeated this experiment for different temperatures, and we've got the different amount of the different time periods needed to produce that same amount of sulfur, and then mean that we've got that cross disappearing. So yeah, the precipitate we formed is sulfur that we've got in there. So on the screen in a minute there will be a sample set of results, so you can copy these down. And then you need to continue through the questions, looking at considering your results and conclusions, and then evaluating the experiment as well.